when we have density function defined on an interval, A or B, and we put it like probability between A and B. dB is in the top and A in the bottom, and we put the function, and then we have the properties. Always the result of the function is greater than 0, and if we have an interval that is with infinite, we put the function and is equal to 1.
For the density function of a continuous random variable, f of x equals 12x squared minus 3x cubed over 64, defined on an interval between 0 and 4. First, we're going to find the probability between 1.7 and 2.3. We need to put the intervals, the biggest one on the top and the small one on the bottom. And then we copy this here. 12x squared minus 3x cubed over 64. And it's important to put the x at the end. It is easier to solve it with the calculator, so we type 12 alpha x squared minus 3 alpha x cubed over 64 and define the intervals 1.7 and 2.3. We copy the results over and it's better to put it in decimals, only 2, so it's 0.22. Next, we're going to find the probability, which is greater than 3.4. As we don't have another interval like here, we need to use the 4, this 4. So we will write it like this. Probability x is greater than 3.4. So, as mentioned before, we use the largest here, and then 3.4 here, and we copy the same problem, 12x squared minus 3x cubed over 64 dx. Again, we type it on the calculator. Alpha x squared minus 3 alpha x cubed over 64, and just make sure to change the intervals 4 and 3.4 equals. And finally, we copy the result. 0.1095 equals 0.1.
Okay, so here we write the probability of x is less or equal than 2.7, and we put the derivative. We put 2.7 on the top because it's the greater, and as we don't have any other, we use the 0 of the interval here in the bottom, and we put the part of the problem, that is 12x squared minus 3x to the cube divided by 64. Sorry. And finally we put here, and then we put this in the calculator. We plug the derivative, and we write the problem. And we also have to put the values. And this is the final result. The expected value as we don't have here any interval like these ones, we're going to use the ones of the beginning. So here it will be, the 4, here the 0, the f of x, that will be 12 x to the square minus 3 x to the cube divided by 64 dx, and this will be times x. And then we type it in the calculator. And this will be the final result. Or we can change it to decimal. That will be 2.4. And both answers are correct.
For the variance, we start with the expected value that we have already done in the exercise before. And we start plugging for 0 in parentheses x minus the expected value, which is 2.4 to the square times the x, which is 12x to the square minus 3x to the 3 over 64. And then we plug in. Then we start plugging each element of the equation times the function, the original function, which is 12x to the square minus 3x 3 over 64. And we put 4 and 0. We get 16 over 25. 16 over 25, or in decimals, which is 0.64.